Now let's look at some sets whose elements are actually lists. And although this sounds very complicated, actually it's not, and it's something that you are very familiar with already. So for example, R2, which is our notation for the plane, this is all collections of pairs A1, A2, where each coordinate A1 and A2 are both real numbers. And we also have R3. So R3 is the collection of all ordered triples, where each entry is a real number. And so on, right? And so in general, we say that Rn is the collection of all ordered n tuples of real numbers. Okay. Similarly, since we're going to be talking about complex numbers, we may also talk about C2. And so C2, this might be all pairs alpha 1, alpha 2, where each alpha is a complex number. And similarly, we'll be looking maybe here and there at C3. So this is the collection of all ordered triples of complex numbers. And of course, we can also have ordered n tuples. All right. And then for statements that can be true for both R and C, so for both the reals and the complexes, in order to save time and ink, we use the boldface F. And F stands for the word field. In cases where either or both will work. So similarly, within our convention for the notation, Fn can mean either Rn or Cn. Okay, and there's other fields besides R and C, and I'll make a little optional video clip for you to look at if you're interested in what the word field means and so forth. We might also talk later on about Fn comma m, so two exponents up there, and that'll be our notation for n by m matrices. With entries in F.